Okay. Good morning, students. Today, in this class, I am going to explain two more problems. I have taken problem number 15 and 16. So, these two problems are related to lenses. The first problem is solved on the basis of lens maker's formula, and the second problem is on the definition of magnification. So, I will explain how to solve these two problems. So, first of all, let us read and try to understand the problem carefully. See here, an equiconvex lens of glass of refractive index 1.5. Equiconvex lens is given. Say it is an equiconvex lens. You know what is equiconvex lens? A lens having both the radius of curvature. Say it is the first curved surface and this is the second curved surface. See here, for both the curved surface, if the radius of curvature is same, such a type of lens are said to be equiconvex lens. So according to given data, equiconvex lens is given. Equiconvex lens means radius of curvature for the first surface is equal to radius of curvature for the second surface. See here, is immersed in a liquid. This lens is immersed in a liquid. Say it is a container filled with water. It is immersed in a liquid of refractive index 1.6. So let us consider the refractive index of the liquid is NL. NL is equal to 1.6. The refractive index of the glass is NG. NG is also given 1.5. Now the light is traveling from 1.6 to 1.5. Say in this direction, let us consider light is traveling. So that's why radius of curvature. If the radius of curvature of each surface is 0.1 meter, first one, second one is also same 0.1 meter. But the very important thing is while taking the sign convention, say it is the first curved surface and this is the second curved surface. For the first curved surface, the center of curvature comes somewhere here. We are measuring from center to the center of curvature. It means optic center to center of curvature. So here to here the distance is taken as positive because we are measuring along the direction of incident, right? That's why the first one, R1 is positive. For the second curved surface, the center of curvature comes somewhere here because this curved surface is the part of this sphere. The center will come here. That's why we are measuring from here to here. We are doing the measurement against the direction of incident, right? That's why we have to take negative here. This is very important thing. So we have to take negative here. So R1 is positive, R2 is negative. And both the refractive indexes are given. Refractive index of liquid is equal to 1.6. Liquid is 1.6 and refractive index of glass is 1.5. Refractive index of glass is 1.5. See what we need to calculate in this problem, that is very important. Find the nature and focal length. So nature means how this lens can behave after immersing this liquid of refractive index 1.6. So it means nature means whether it may behaves like a convex lens or concave lens, depending upon the sign will decide. So after getting the value, we will decide whether it is what type of lens is formed. Now to find, so here we need to find the focal length of the new lens when it is immersed in a liquid of refractive index 1.6. So to find the focal length, F, so we know that there is a formula called lens maker's formula. Lens maker formula is represented by reciprocal of focal length is equal to n minus 1. Here, we are not supposed to take n only since the liquid is surrounded by this lens. It means light is traveling from not from air to glass. It is traveling from liquid to glass. That's why. So, liquid to glass. This is very important. See, liquid to glass is light is traveling. That's why L to G minus 1. Of the formula completion is 1 by R1 minus 1 by R2. This is the relation what we call the as lens maker's formula. This will give the relation between radius of curvature, refractive index and focal length. So So it is called lens maker's formula. We are using this formula to solve this problem to find the focal length. So whatever the focal length is obtained is, let us consider f. So now substitute all the values. 1 by f is equal to, here refractive index of second media with respect to first media means Ng divided by NL. Ng divided by NL minus 1, because the definition of refractive index itself says that refractive index of second media with respect to first media of 1 by R1 minus 1 by R2. In the next step, I am going to substitute all the values to find the focal length. 1 by f is equal to Ng. Ng value is 1.5 divided by N refractive index of liquid is 1.6. 1.6 minus 1. 1 divided by R1. R1 is plus 0.1. R2 is, here it is minus, and in the formula it is R2 is minus. Formula minus, and the value of R2 is also minus. Here I want to write one more step, minus 0.1. So this minus and minus will become plus in the next step. I am going to take positive here. So in the next step, let us take 1 by f is equal to, after simplifying this, take the LCM of this. 1.6 is LCM. 1.6 is LCM. 1.6 minus 1.5 minus 1.6. 1.5 minus 1.6 of, here minus of minus plus 1 by 0.1 plus 1 by 0.1, it is 2 divided by 0.1. So in the next step, only thing is the simplification step is remaining. So 1 by f is equal to 1.5 minus 1.6 is 0.1 with negative sign, because it is 1.5 minus 1.6 is minus 0.1 whole divided by 1.6 into, here it is 2 divided by 0.1. So 0.1 get cancels. The next step, 1 by f is equal to minus 2 divided by 1.6. See here, 1 by f is minus 2 by 1.6. Then if I take the reciprocal of this step, reciprocal means you have to take the numerator to denominator transformation. It will become minus 1.6 divided by 2. F is equal to 1.6 divided by 2 is 0.8 meter. 1.6 divided by 2, the value of 1.6 divided by 2 is 0.8 meter. So this is what the focal length of the lens when it is immersed in a liquid of refractive index 1.6. So this is very important. See, focal length is negative. Now we are getting negative focal length. So what type of lens we are getting negative focal length? The lens is having a concave nature. If the lens is having concave nature, then you will get the negative focal length. Now the behavior of this lens is, the nature becomes concave nature. Nature is concave. Why it is concave nature? If the refractive index of the surrounding media is greater than the refractive index of the lens, at that time the lens, the convex lens behaves like a concave lens. So actually convex lens is converging lens. When it is surrounded by a refractive index of a liquid which is greater than the refractive index of the lens, at that time this lens behaves like a diverging lens. Diverging lens is called concave lens. Converging lens is called convex lens. Now actually it is a converging lens. Since it is surrounded by a high refractive index compared to this refractive index of the glass, that's why the convex lens in this situation behaves like a concave nature. So this is a important thing, because we have to represent, find the nature. The nature at this situation is concave nature, right? So I request from all the students, please copy this problem. I will continue the next problem. Okay, let us move on to the next problem, that is problem number 17. So first of all, I want to read this problem. An object of 0.03 meter height stands on the axis of concave lens. See here in this problem, concave lens is given. It is a converging lens of focal length 0.3 meter at a distance of 0.15 meter from it. Find the size of the image formed. So we have to find the size of the image. See, according to given data, an object of 0.03 meter height, say it is a concave lens. Say it is a concave lens. This is what the principal axis. To this principal axis, an object is placed like this, in this direction. So the height of the object, let us consider is HO. HO is the representation of height of the object. HO is equal to given 0.03 meter. See, I used to take here it is positive because it is in the upward direction. If it is above the principal axis, we have to take the positive value according to sign convention. Stands on the axis. This is what the axis, it is standing like this on the axis of concave lens. See, it is a concave lens. It is not a diverging lens. It is a diverging lens. Concave lens of focal length. Focal length is given. F is equal to 0.3 meter. See here, for concave nature, we will get a negative sign. So that's why for concave lens, the focal length should be negative according to sign convention. It should be negative sign. At a distance of 0.15 meter. From here to here, the object distance is given. We are measuring from the center to the object position opposite to the direction of incident. This is what the direction of incident is. We are measuring from here to here, so it is a opposite sign. So I have to take the negative here. U is equal to how much the value here at a distance of 0.15 meter. So it should be negative since it is opposite to the direction of incident ray. So that's why U is taken as negative. So from here to here it is U. So the image is formed at certain position. So we have to find that value, image position value. If you know the image position and object position, one can find the height of the image. See here, find the size of the image formed. So size of the image means HI we should find in this problem. To find HI, first we should find the image distance. Object distance is given. First of all, we have to find the image distance. So for that, there is a formula called lens formula. So we know that the lens formula 1 by F is equal to 1 by V minus 1 by U. So F is given, U is given. So we can find V. So we simplified for V. So if I simplify for V, we will get 1 by F. Substitute the value here. 1 by F. F is how much? Minus 0.3. Minus 0.3, which is equal to 1 by V, that is what we call what we calculate. 1 by V, 1 by U. U is equal to, here it is, negative again, U is equal to minus of minus plus it becomes 1 by U. U is equal to 1 divided by 0.15 now. Now simplified for V. If I want to simplify for V, see here, I want to transfer from here to here or here to here. 1 by V will take. 1 by V is equal to, if I transfer from here to here, it will become negative. Minus 1 divided by 0.3 minus 1 divided by 0.15. For the sake of simplification, if there is a fraction, it is difficult to simplification, or else you can use the calculator. So better you simplify it in terms of 100. See, multiplied and divide by 10, it will become minus 10 divided by 0.3 into 10 is 3 only. Minus here it is 2 numbers, divided multiplied by 100. Multiplied by 100, divided by 100. Divided by 100 is nothing but that number should be multiplied by 0.5. It is 15. Isn't it? So now we take the LCM. If we take the LCM, 10 into 15 into 3, 45. We take the cross multiplication. This is 10 into 15 is 150 minus 150. Here it is minus 3 into 100 is 300. So the value becomes 150 minus 150 minus 300. It is minus, the value becomes 450 divided by 45. It is 1 by V. Now, in the next step, I want to consider this reciprocal of this value. If I take the reciprocal of this value, it will become V is equal to minus, it is 45 divided, or you can take 150 divided by 45. 150 divided by 45 is 10 only. 150 divided by 45 is 10. 10 times it is minus 10. 1 by V is minus 10. Then what about the V value? Reciprocal of 1 by 10 only. 1 by 10 you know that. What is the value of 1 by 10? It is 0.1 minus 0.1 meter. This is the value of image distance. We are getting image distance as negative because since it is a concave lens, it is always produces virtual image. The virtual image should be having negative sign. Here it is diverging lens. This is what the direction of the ray which is appears to diverge from the principal focus. Now another ray passing directly to the optic center without deviation. Here the image is formed. This distance from here to it is called, that distance what we call them as image distance. Image distance what you are getting 0.1 meter. Now in this problem we have to find this height of the image. This is object, A, B is object, A dash, B dash is image. To find the height of the object, we know that magnification M is equal to height of the image to the height of the object, which is equal to image distance divided by object distance. Use this relation to calculate the height of the image. Therefore, height of the image is equal to height of the object into image distance divided by object distance. You have to take. So, what is the height of the image? They have given 0.03 into image distance and object distance both are negative. Negative get cancelled. Directly I will take the value. V is equal to 0.1. U is equal to 0.15. If I use the calculator to simplify this, we will get an answer of 0.03 0.1 divided by 0.15. We are getting 0.03 into 0.666. We are getting 0.666 multiplied by 0.03. It should be, which is equal to 0.019. This is height of the image. It's in meter. 0.019 meter. Therefore, height of the image becomes 0.019 meter. This is the value of height of the image. .019 meter. We will get an answer of 0.019 meter only. It is almost equal to 0. Approximately height of roughly equal to you can simplify this as 0.019 is almost 0.02 meter. Or you can keep this one only, no problem. So this is the answer. The height of the image is 0.019. See here we are getting positive only because both the object and image are in the same direction. So both are the perpendicular to the principal axis and they are in the upward direction above the principal axis. That's why. So this is what the method to solve the second problem. So in the second problem we are using the definition of lens, or we are using the formula of a lens. This is lens formula, and also the definition of magnification. So, but in the previous problem, problem number 15, you have taken lens maker's formula to solve this problem. So I kindly request from all the students, copy these problems in your notebook and send to my personal ID. I will verify. Thank you.